Well, hello YouTubers and retro computing nerds everywhere. Welcome back to my channel, and today I'm a little excited. I'm starting on a project I've been wanting to do for a while. I am building a Z80 MBC2 retro computer. Retro-ish. It uses, some modern parts in it, basically an Arduino compatible chip in it, but it does have a Z80 processor. So it's going to be a true Z80 computer. And it's taken me a while to find all the parts. Get this box over here, this big collection of parts over here. It's taken me a while to collect all the parts, especially with COVID and supply chain shortages, but I think I finally have all the components I need. And I got my parts layout list here, and the first parts have gone into the circuit board. I bought this circuit board on eBay. There's lots of places you can get them, but I got this one on eBay. And it's just been sitting here for a while. I've been collecting parts, and then once I got all the parts, I had to find the time to start working on it. But today was the day to start working. I've actually got a few parts, a few components inserted in the board. I've got to take them out into my workshop and solder them in, and then trim the leads, and then put some more parts in. And it's probably going to be a multi-day project because I don't have a whole lot of time to work on this every day. So it'll probably be a multi-day project to get all of the parts soldered in, and then probably a couple more days to get it powered up and see if I can get it, working. But hopefully I'll have soon a Z80 computer up and running that I can use to help debug some of my other Z80 computer projects, retro computing projects I've got going on, which none of them are running at the moment. And it would be nice to have a running computer to help debug them and get software going. I'll get CPM up and running on this, and that will be a big help in getting the others up and running, I'm sure. So at least the project is finally started. So this is day one of the MBC2 Z80 computer build. We'll see how long it takes, and I'll give you regular updates. Okay, it's the next day, and I've been working on this a little bit for about the last hour or so. I've got, as of now, all the passive components installed, the resistors and capacitors, plus the crystal, transistors, switches, and LEDs. It's been a while since I've done a major soldering project. It's good to be back in the saddle again. I was an electronic engineer, but I got promoted into management, and I haven't worked a soldering iron much in the last, 15 years or so before I retired. So it's good to be doing this again, building stuff. There's sort of an order to the way you do things when you're putting stuff like this together. Basically, you want to do the short components first. I did all the resistors first and diodes because they're short, and I did the disc capacitors, they're short, and I did the crystal. Then I got the switches, the transistors, and the LEDs because they're all about the same height. And just, you hold them in place with tape. After you get them set where you want them, hold them in place with tape, solder the back, clip the excess leads off, and then go to the next highest set of components. There is one gotcha here. I've got the bill of materials up on my computer just off screen here. You can't see it. And I think it's the user LED. It has to be white. No, it has to be blue. It has to be blue. Blue or white, I think it is. Somewhere in the write-up on this thing, they talk about that. So the LEDs aren't just chosen for aesthetic purposes. The low voltage drop across the the blue LED is important apparently for the circuitry. So you watch the colors. So you got we got 2 whites, a red, a green, a blue, and another red up here. And that's the way it has to be apparently. So watch out for that. Okay. Next up, I think, pardon me while I reach through the shot. Next up, I think, are the Icy Sockets. Some Icy Sockets here. And yeah, sockets. So I think next up I shall put the Icy Sockets in, and I'll hold them down with tape while I go out in the workshop and solder them in. That may be tomorrow though, because it is a little after 5. The wife's going to be home shortly. It's Friday night, and I told her I would take her out to dinner. So I think we'll do that. So I might have enough time before she gets home just to get the sockets in and taped down, and then I'll solder them in tomorrow. And maybe I'll let you watch over my shoulder while I solder. After the sockets, then it's going to be the headers, the tall electrolytic capacitors, and that's about it. It'll be about time to put some power to it. Make sure that the power is getting distributed to where it needs to be, and then put chips in and test it out. So making some progress. It's going a little quicker than I thought, but it still may be a day or 2 week before I'm ready to try and fire this thing up, just because I got a lot of other stuff to do. But let me see if I can get the sockets in and taped down tonight. And I'll show you when I'm ready to solder them in. Okay, it's the next day. I got a little bit of time here. I'm working on some projects outside, so I don't have a whole lot of time, but I've got the sockets taped in, and I'm gonna solder them into place. So hopefully I can do this without A, blocking the camera too much, and B, without screwing the pooch and either getting some solder bridges or cold joints or other issues. So here we go. A couple over here just to hold the socket in place so it doesn't shift, and I'll just go along and do all of the traces, or all the pads. Not too bad so far. Like riding a bike, you never forget once you learn. Those look like some pretty, for the most part, some pretty good joints. That one could use a little work. Alright. Time to clean the soldering iron. Doesn't look like a very good joint. There we go. That's better. Okay. Okay, and there's the first one. All 32 pins soldered in. Alright. I got a couple of 40s. Actually, it's 14 right here. Do it. This computer only uses 5 chips, and one of them is optional. I/O port expander, but I'm exercising the option. I'm putting it in. Right. Actually, yeah, here's the I/O port expander over here. And there we go. Now the pins are sticking up. do it. Clean the soldering iron tip again. At least I won't have to trim the excessively long leads on these sockets like I had to do with all the resistors and all the capacitors and the diodes and the LEDs and the crystal, the transistors. Yeah, the leads on the sockets are just long enough. So let's do one of these. Let's do one of these 40s here. Keep it in frame. Yeah. That looks better. Okay. Just to hold these sockets in place. And do a couple just on either end just to hold these sockets in place. So they don't shift. Then I can just go down the line and do them all. Yep, it helps to have really steady hands. I'm glad, even at my advancing age, I've still got pretty steady hands. One place I used to work, our chief engineer, his hands shook real bad, so we were always joking that I was his hands. He'd have the ideas and I'd have to implement them. Let me just do a little quality control checking here with the lens and look and see if I see any bad, obviously bad joints or solder bridges. So far, it's all looking pretty good. I do see one or two joints I should probably just go over just out of an abundance of caution. And I think, did I forget to put in a resistor network? Yeah, I've got to install another resistor network. Huh, how did I miss that? I should have been marking stuff off on the bill of materials. Another resistor network goes there, just like that one. Okay. I will put that in. couple. I'm going to go over, like I say, just out of an abundance of caution. They all actually look okay, but you know, just to be on the safe side. Okay, good. Alright, so next I'm going to put in that resistor network that I missed before and the headers and solder those in. And maybe the big tall electrolytic capacitors. And there's not a whole lot left to do after that. We're getting down to the nitty-gritty. Okay. Let me see if I can find those parts I want to put in next and at least get them taped in place today. It might be tomorrow before I can solder them in though. Alrighty, it's been a couple of days. I've got some time to work on this again. Today's going to be headers and electrolytic capacitors, and that's going to be mostly, I think, going to complete the construction of this thing. So I've got all the headers taped in. Just need to flip it over and solder them in place. Then tape the capacitors in and solder them in place. I'll do like I did the IC chips too. Each end of the headers, that's a big blob of solder. Let me see if I can get some of that off there. That's better. Do each end of the headers. This one's only got 2, so that's easy. Come on, solder, flow. I'm going to have to rearrange my tape. It's almost completely covering that one. But I'll get it. It's not going anywhere now. I can take this tape off, get it out of the way. Yeah, but that one's still going to be a problem. Rework that a bit. Okay, that looks pretty good. Do this one, then I'll rework the other one. I think I might have called this computer a kit computer at one point. I don't know if it's technically a kit if all you get is the PC board and you gotta locate all the parts yourself for finishing it. I guess it could still be called a kit. What's going on here? I don't know. Solder's being very globby today. I don't know what's different. I may have bumped the temperature knob on the soldering iron. I think it's where it needs to be, and it looks right. Maybe it's just the way these headers are tinned. These came out of my junk box. I didn't actually buy these. Who knows how old they are? They might have a little oxide coating on them. Look at some of these solder joints here. They look okay. Let's see. Yeah, there's just a little ball of solder there off the side that came right off. I don't see any bridging, don't see any obvious cold joints on anything I've soldered so far. Okay. Look at that. That's good. Alright, let me rework this tape over here. And rework that tape there. Hold this down a little bit without being in the way. Yeah. And then I got these female ones to solder in. I almost screwed up and put male headers in here, but these two need to be female. Tape's not holding that down far enough. Okay, now I think I can solder it. Be careful of gotchas like that. Okay. Look at these joints. Well, I completely missed one. Okay, I need to do that. Otherwise, they look okay. How did I do that? I completely missed one over here. Never hurts to double check. Okay. I will probably eye over the entire board here a little bit once I'm done, just to make sure I haven't made any other bonehead mistakes. There's all the headers in now. Okay, now it's just electrolytic capacitor time. I only got a couple of them to put in. And then all the holes are filled. I had to buy a bag of 100. Spend the next year assembling these computers with all the extra parts I've got. There's one. There's the other. Put a little. I don't know if I need tape on them there. They're like the tallest components on the board, so the board's resting on them. I guess I'll just solder them like this. Huh. Okay, come on. There we go. The solder's just not flowing that nice today. I'm not sure what the problem is. There we go. Trim off the excess length. The old Mark I calibrated eyeball on it. Looks pretty good. A few solder balls. I may go after the board with like a stiff toothbrush or something and see if I can knock some of these solder balls off. Just so they don't migrate somewhere they shouldn't be and cause a short. Otherwise, it looks pretty good. Not bad for being out of practice. Yeah, not too bad at all. Alright. I will brush this board good. And then the next step, when I get to it, which may not be for another day or two, is I'm going to have to put power to it and measure that I'm getting the proper voltages at all the IC chip sockets. And then I can actually put the ICs in and we can move on to testing it as a computer. Should be interesting. Alright. I'll be back. Alright. Another day. Got a few more minutes to play with this. Today what I want to do is I'm going to power it up and I'm going to make sure that I'm getting plus 5 volts and ground connected to the right places on all of the IC sockets and also all the other headers that are supposed to have 5 volts and ground on them. But first up front, I have to admit I screwed up. I made a mistake. I soldered in the wrong kind of female headers for where the SD card and the real-time clock module plug in, and neither module would plug into those headers. I soldered the wrong headers in because I couldn't find the right ones. I knew I bought them, but you know, it took me months and months to accumulate all these parts, and somehow I misplaced these. So I was all set to unsolder these headers I put in there and solder the correct ones in when I realized the correct headers will slip into the headers that are there, so I can still connect the SD card and real-time clock module when I'm ready to do so. That's not going to be today, but okay, so at least I don't have to get the desoldering tool out and fix that screw up. Alright, so let's get started here. Let me put the meter 20 volt scale, turn it on. I've got this little USB power pack here, solar charged, and plug it in, turn it on. Turn the lights off. There we go. Alright, so we should have power here. Let me double check that we're actually getting juice to the board. No smoke yet, that's always a good sign. Let's see here. That is really not obvious which pin is. Huh. I don't think I'm getting any juice from my power pack. Well, actually I just saw a light, so there was some juice there. Let me see here. Let me double check that there's juice coming in. Yeah, there's juice coming in. Okay. Let me put this back on the correct way. Yeah, if I push the user button, I get a light. Okay, good. I'm not seeing any power on this header here, though. Oh, there it is. Okay. Okay, yeah, see the silk screening is a little bit off. It's not really obvious which pin the screening applies to. Okay. At least not from the angle I'm sitting at. Okay. So we got power there. Let's see. Power up here. Yeah, we got power up here. Okay, good. So let's see. The Atmega 32A is plus 5 volts on pin 30 and ground on pin 10. So let's see here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 40, 39, 38, 37, 36, 35, 34, 33, 32, One, whoops, I must have miscounted. Power, okay. Alright, and then let's see, the Z80 gets plus 5 volts on pin 11, and ground is on pin 29. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 29. 1, 2, 3, 4, 5, 6, 7, 8, 9. 29. And there we are. Okay. Let's see, the 7400 courses. Plus 5 volts on 14 and ground on 7. Yep, okay, that's good. And let's see, the RAM chip on 32 and 16. Got juice there. And then the I/O expander, the MCP23017. Interesting, 9 and 10. Plus 5 volts on 9 and ground on 10. So let's see here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ah, okay. Looks like we have passed the initial smoke test. We got power going everywhere power needs to be. We haven't blown up any capacitors. Even got an LED that lights up when I push a button, so that's kind of cool. Is that showing up? Yeah. Get my finger out of the way. So, it's time to put the chips in and give it a real test. So I will do that, and I will hook my laptop up to it with putty running, and we'll see if we can talk to it. Might actually have us a computer here in a minute. So here's all the chips. I bought a chip set on eBay. You know, I got the board on eBay and I bought the chip set on eBay. So you can find great stuff on eBay. Now supposedly the Atmega 32 is already flashed with the proper firmware. We'll see if that is the case. I have the doohickey for flashing it if I need to. I bought that before I bought the chip set, so I have that. But we'll put the chips in and we'll see what happens. Put some power to the thing. Sure all the little legs are in the socket properly. Yep. Alright, so there's one. Here goes the Z80. 8 megahertz Z80. Boy, would have killed to have one of these back in the day. Okay. This one's fighting me a little bit, but I don't want to force it. Make sure all the legs are lining up. This Z80 just does not want to go in the socket. There we go. I think. There we go. Alright, all 40 legs in their socket holes. Now for the RAM chip. This RAM chip has obviously been salvaged. removed from some older piece of equipment. I see solder on the legs. That's not going to make it easy to get it in the socket. So I got nothing against salvaged parts. I salvage parts myself for my projects. You know, I've got a little side business extracting precious metals from electronic waste, but sometimes the electronic waste isn't always waste. It's got a lot of good stuff. And, you know, I've been known to salvage chips and reuse them. They're easy enough to test. I have a video, a couple of videos about testing salvaged chips. Okay, the legs on this chip are just not cooperating. Doesn't help that the lighting out here isn't great. Normally the lighting out here is great when I'm working out here, because I work out here in the afternoons and it faces west, but today we got a bad storm rolling in and it's kind of dark outside. Okay. These pins, legs need a lot of reshaping here. They are sprung way too wide. They don't want to go in that socket. That's better. All 32 of them lined up. My glasses off and use my nearsighted superpower here. Yeah. One good thing about being profoundly nearsighted is I can see really close up. Okay. A couple of legs need a little bit of reshaping here. Realignment. Can't remember, but I believe I tested this chip to make sure it was good, because I could tell it was salvaged. I may have more if this one doesn't work for some reason, or if I can't get it to get in the socket. Okay. Tell you what, let's put the 7400 in the socket. Actually, 748C00. We'll put it in. And I will work on getting that RAM chip installed off camera. You don't have to watch me struggle with it. Okay, it looks like we're pretty much ready for an almost all-up test. I don't have the SD card installed, and I don't have the I/O port expander installed yet. But I do have it hooked up to a serial dongle here, and I'm going to plug this in, and that'll power it. And okay, lights coming on. Interesting. Now, as I understand it, I'm supposed to press reset, hold down the user button, let up reset, and wait until that iOS light comes on. Okay. So let me start up PuTTY, which is going to be on COM9, which just appeared on my device list. Serial COM9, baud rate 115200. Open. Uh-oh. Okay, well, it's telling me over and over again, I don't know if you can see that, that the SD card is not ready. But I will take that as a win. We're communicating. Of course the SD card's not ready. It's right here in my hand. It's not plugged in yet. So, but I will take that as a win. It is up and running. Okay. So let me shut down PuTTY. Let me unplug, take the power down. Alright, we got something going on here. Anyway, so the firmware, there is firmware in that chip. It's looking for its SD card. So I copied the files from the MBC2 Hackaday article. The files, I copied them onto this SD card. We'll see what happens now. So we restart this. Serial 9. 5200. Open. Oh, something went by really quickly. Oh, interesting. It's still complaining about the SD card. So I obviously haven't done something right with it, but let's see. At the very top, when it first opened up, what did it say? Let's see, hopefully it hasn't gone out of the buffer. There it is. Found extended serial RX buffer. Z80 clock set at 8 MHz. CPM auto exec is on. Current disk set 2. Then it starts with the SD error 6. No file system on mount operation. Check SD and press a key to repeat. Well, okay. It's just printing that over and over and over again. Too fast for you to see. Yeah, okay. So I did something wrong with the SD card, obviously. I guess I probably needed to do something besides just copy the files over. Maybe I needed to reformat it a certain way or something. I will read up on that and see what's going on. But hey, it's working. It's running. It's communicating. That's cool. It's up and running. I'm a happy camper after all that soldering. I think we just got a software issue here I need to solve. And see if we can get something more out of it. So I'll be back when I've got this sorted out. Alright. When last I left you, the computer was kind of working. It wasn't exactly working right. It was giving me an error about the SD card. And I did some research that evening online and figured out the problem. The problem was the SD card I was using was too big. It was a 64 gig SD card. I was looking around on the Z80 MBC2 Facebook group and found out that I needed a much smaller SD card formatted in FAT16 or FAT32 to work. So I scoured all of my stuff and I found that I had exactly one SD card that small. And it was the card I used with my 3D printer. So I had the little bit debate a little bit because I use my 3D printer every freaking day. So it's like, okay. But I wanted to get this up and running. So I said, okay, maybe the card can do double duty. I ordered some more 8 gig cards off of Amazon. So until they arrive, this card's got to do double duty. So put the software on this card, plugged it in, and guess what? It all works. It all works. Let me plug the RS-232 dongle in, and I don't know if I explained before now, the power for the board is coming from the RS-232 dongle these days. I was powering it with the little power pack for the initial tests, but now it's coming from the RS-232 dongle. And this is a TTL level RS-232, USB to RS-232 converter. You'll need one of those. So let me start up Putty over here and I'll show you what we got going on here. Let's see, COM 9, baud 115200, open, and look at this. Look at this. CPM. It's loading CPM. Yeah, zoom in on the screen a little bit. And there's a little auto exec program that runs, which is kind of annoying. I think I'm going to have to disable that. But on a cold boot, it runs this auto exec program that basically just blinks the user light down there. And it'll keep blinking until I press the user button. And then it'll say, okay, program terminated by user key. So now I'm in basic. I'm in basic. So if I do list, I list the program that just did all that. So, okay, but if I want to get out of basic, I'm going to type, whoops. Okay. Another thing, to get communication between the two right, I need to change some settings. Basically, the settings in Putty are force local echo on and force local line editing on. Apply that. And now, if I screw up, I can backspace. Okay. So, I gotta type system in uppercase, and the system will reboot. CPM 2.2, look at that, we got a CPMA prompt there. What do you know? DIR, and we've got all this stuff on the A drive. And there's quite a bit of software here. Let's see, we've got a B drive. Takes a few seconds to mount it. Do a DIR. And we've got Turbo Pascal on the B drive. Let's see what's on the C drive. What the heck is on the C drive? Let's see, is there a README? Yeah, there is. Oops. I can't type today. It is early in the morning, in my defense. The high-tech Z80 CPMC compiler version 3.09 provided free of charge for any use, yada yada yada. Okay, so that's nice. It's on the D drive. Just Fortran? There a README? Yeah, there's a README. Microsoft Fortran 80 compiler version 3.44. Okay. Is there an E drive? Yes, there is. There's no README on. Oh, there is a README. Oh, the heck is all that? Microsoft Basic 80 compiler. Okay. A basic compiler. Cool. F drive. Okay, the F drive's empty and everything above F is empty. But that's cool. We got all these drives, and this is just CPM 2.2. If I do a reboot while holding down the user key, or reset while holding down the user key, I will get this screen here, which allows me to change the disk set. And there's CPM 3, there's QPM, there's all kinds of stuff. I mean, go to the documentation on the MBC2 and read it for yourself. There's all kinds of stuff on here. But I am really stoked that this thing is working. And it's working, you know, basically on my first try. It's working. It works perfectly. At least so far. I've got a couple of other things I want to do. I haven't put in the GPIO expander chip yet. I need to do that. And I need to do the real-time clock module. Apparently, the real-time clock module needs to be modified. Everything I see in the documentation says the battery may explode unless you modify it. So I need to modify it and install that and make sure it's working. But yeah, we're up and running. So this is cool. So let's have a look at some of these other options here. So right now we're on disk set 0, CPM 2.2, but if I press number 8 at this screen, it gives us the option to change. So we've got QPM 2.71. Never used QPM, so I'm not terribly familiar with what it is. CPM 3.0, which is nice. I actually booted up into that and played around in it for a little while. UCSD Pascal. So we've got Turbo Pascal and we've got UCSD Pascal. Pascal was probably the second high-level language I ever learned when I was young. So it'll be nice to play around with Pascal again. And sort of a little trip down memory lane, nostalgia. Collapse OS. I never really played around with Collapse OS. I'll have to do a little bit of reading up on it and see what it's all about. And for now, we'll go back to CPM 2.2. But it's got all kinds of stuff, and of course, each of these is just loaded with stuff. I mean, the CPM 3.0, all the drives are loaded with software. There's all kinds of stuff there. It's just, this whole thing is, it's all stored on the little SD drive. It's incredible how much stuff is crammed on that little SD drive. I mean, back in the day, you'd have been swapping disks like crazy to access all this stuff. So we're back to CPM 2.2. Uh-oh. Bad sector on A. Fortunately, I don't know what caused that. I see the occasional little error, but if I just reset it, it comes right up. So I gotta press the little button because it's blinking the LED again. And system, and here we are. CPM prompt, back at the A prompt. Alright, so I'm really stoked about getting this thing up and running because I'm hoping it will help me get some of my other retro computing projects off the ground, because now I've got one that I can write and compile code on, write and test and compile code on, and then I can transfer that code over to the other systems and make sure that they're working properly. I've got one in particular, my Teletech System Master single board computer, that I would really like to redo the monitor ROM on it. So I think this will help me out tremendously with that project and some other projects like my breadboard computer, which is starting to come along. So like I say, I'm stoked. I got my MBC2 Z80 computer up and running. It works. I'm happy. I'm a happy camper. Well, I hope you found this assembly and testing of the Z80 MBC2 computer interesting, informative, educational, whatever. Give the video a thumbs up, give it a like, and subscribe to see future videos. I've always got new videos coming out. There's a lot of them on my channel already. Check them out, and press the little bell icon that YouTube makes you press to be informed when new videos come out. And thanks for watching. I'm a happy camper. I hope something makes you happy today too. Bye.